Hello, my friends. I'm Clover, and this is Genuinely Approachable Sudoku. And today we are solving Irregular Given by Philip Newman. This is the second day of our August 2025 Guess the Next Variant month. There is a way to determine what tomorrow's variant will be. I'm not going to say any more than that yet. I will probably be dropping other hints throughout the month. But there is a way that is accessible to you, person watching this, to determine what tomorrow's variant is going to be. And you have all month to try to figure that out. So let's solve this puzzle. So this is an irregular Sudoku, meaning that we're placing the digits 1 through 9 once each in each row, each column, and each wiggly region, not the typical outlined 3x3 regions, but wiggly regions. And that's it. So the first thing that jumped out at me when I looked at this are these 2s and these 1s, because they see, in the case of the 2s, all of these cells in this region, meaning this is the only position remaining for a 2 in this wiggly region. Similarly, there is only one position for a 1 in this wiggly region. So now there's only one position for a 2 in this region, because we have 2, 2, and 2, and a 2 there. And here we have 1, 1, and 1, and that is now the only position for a 1 in this region over here. So the next thing I noticed is that I now have all of the odd digit, or all of the even digits here, and all of the odd digits here. So I need even digits there. I need 2, 4, 6, and 8. I can eliminate 2 from those cells because there's a 2 up there, and I can eliminate 6 from here, and 4 and 8 from here, and 6 from here, just by Sudoku. And these are going to be 1, 3, 5, 7, 9, and I can eliminate a 1 from here because there is a 1 right there, 5 and 7 from there, and 9 from there. And that's probably not the tidiest way to go about this, but I'm going to go ahead and leave that because that is genuinely the next thing that I saw while I was solving this. These are also going to be odd because in the row, we have 2, 4, 6, and 8, so these are from 1, 3, 5, 7, 9. That's not 1 or 3. That is not 9 or 7 because there's a 7 right below it. And these are 2, 4, 6, or 8. I can eliminate 6 and 8 from there because there's 6 and 8 in the column. And I can eliminate 2 from right here. All right. One of these cells has to contain a 2 in order for there to be a 2 in this region at all. So that's not a 2. That makes this a 4. And one of these cells has to contain a 1. So that's not going to be a 1. And unfortunately, that does not give us enough information to determine exactly what that cell is, but we will get around to that. If we look at this wiggly region, we have a digit there now. We have that 4. So we need to still place a 2, 3, 5, and 6. So because we know that one of those cells contains a 6, this can't be a 6. So that gives us a 4, 8 pair, which resolves this to 2 and 6 like that. And it also tells us that the other digit over here has to be from 4 or 8. In fact, because there's an 8 right here, this is the only position for 8 in this region, so that's going to be my 8, and then that will make this a 4 and make that an 8. This is now an 8 because there is a 6 now placed in the row. And the only position for 6 in this L-shaped region is going to be right here. These guys will be 2, 3, and 4. And I can eliminate 4 from 2 of these cells because there are 4s in the columns already, so that's now going to be a 4. Now if I look at this column, which is filling up, I need to place an 8 in it somewhere, and it can't go in these 2 cells, so it has to go here. And then these are from 1, 3, and 5. Now, here on the right side, I still need 5, 6, 7, and 9, and 6 can't go in this top region at all. So the 6 is going to have to go right here, leaving a 5, 7, 9 triple in this region, and a 1 and a 3 here, because there's a 1 in that column, we can determine which way those go. This can't be a 3 now, and neither of these can be 9s because there is a 9 right there. 9 can't be in any of these cells because there's a 9 in the region, so 9 in the row 2 must go right there. Therefore, these guys are 1, 3, and 5, meaning the last digit in this region is a 7. I can eliminate 2 and 6 from here because there are 2 and 6 in the column, and this cell is also going to be a 3 or 5 if we look at the column. Now, this can't be a 2. These 3 cells have to be 3, 5, and 6, and then the bottom row already has a 5 and a 6, so this is a naked 3. This is now a naked 5 because there's a 6 in its row. So that's going to be my 6. And because of the 5 I placed, I can place a 3 and a 1 and a 5 right there. This can't be 5 or 7 because those exist in the row already. And I still need to make 3, 4, and 9 in the row. That can't be a 3. That can't be a 9. Now, if I look at this column, I already have a 3 and 5, so this is now going to be a 2. And this guy has to be either a 4 or 9, but because there's a 9 in the row, that's my 4, that's a 9, and that resolves all this. I can now eliminate 3 from these cells. In fact, I could have done that all along, because there is now a 3 right there. This cell is the only remaining one in this column. It's going to be a 3. That makes this a 5 and a 3. This is the only remaining cell in its row. That's going to be a 5. So I can eliminate 5 from right here. These cells have to contain 4 and 9. There's a 4 in that column, so that's my 9, that's my 4. This has to be 5, 7, or 9, so it is a naked 7 because 5 and 9 are in the row already. That makes this a 5 and a 9, and I think we can resolve everything else by filling in our remaining digits with classic Sudoku. And that is how you solve Philip's lovely guessing game puzzle, August Day 2. Irregular given and irregular Sudoku. Hope you guys enjoyed that one. I definitely did. To check it out yourself, there is a link in the description of this video, and I will see you again in a few days.